Today's class will be discussing about what system. What already mentioned for this particular course, your prerequisite of this course is concerned. It is to provide a strong foundation of fundamental concept in artificial intelligence, provide a basic exposition to the goals and methods of artificial intelligence to enable students to apply techniques and applications for perception, reasoning, learning, distinguish between a conventional and the various artificial techniques in solving problems. In today's lecture, we'll be discussing about two expert systems. One is MySim. While discussing these two expert systems, we'll also discuss about forward checking and backward. Now, this MySim is an expert system, and about expert earlier class we have. MySim uses the backward chaining technique to diagnose factorial, whereas Dendrel employs the forward chaining structure of chemical. Reflected in the diagram, expert system contains three components: one phase, diagram, inference engine, and the knowledge base. And the user interface enables users of the system interact with the expert. High quality and domain specific knowledge is backward and forward chaining stem from the informs. This is a component in logical rules new information or a decision. The backward and forward chaining techniques are used by the inference as strategies for proposing solutions or deducing information in the experiment. Now, what is forward chaining? In this particular topic, we'll see in the reasoning course. Here we'll give a brief overview. A forward chaining is a method of reasoning in artificial intelligence in which inference rules are applied to the existing data to extract additional data until the point of goal is. So, as mentioned, it will start from the existing data based on which the forward be applied. In this type of chaining, the inference engine starts by evaluating existing facts, derivations, and the condition before deducing new information. An endpoint, that is goal, is achieved through the manipulation of knowledge that exists. The output, that is decision, has come out based on the knowledge which already exists in the form and fact to be. Forward chaining can be used in planning, monitoring, controlling, and interpreting applications. Properties of forward chaining are chaining. The process uses a down-up approach, bottom-up. It starts from an initial state and uses facts to make a conclusion. This approach is data-driven. It is employed in expert system and production system. The examples of forward chaining. A simple example of forward chaining can be explained by the following sequence. Suppose we have a fact A, then another fact A determine B, and from these two we are going to deduce another fact, that is B. So the A is the starting point. A determine B represents the facts. This fact is used to achieve a decision B. Like for example, a practical example has A you can consider a storm is running, and another fact which is initial point. Then another fact that a person is running, he will sweat, that is B. And from this one, you can always have a decision like down. The advantage of forward chaining is can be used for multiple, provides a good basis for driving and it's more flexible than backward chaining because it does have a limitation on the data derived from it. Whereas on the disadvantage side, the process of forward chaining may be time consuming. It may take a lot of time to eliminate and synchronize the available. Unlike unlike backward chaining, the explanation of facts or observations for this type of chaining is not very clear. The former uses a goal-driven method and arrives at conclusion. As the backward chaining, you can consider as a concept in artificial involves that involves backtracking from the endpoint goal to steps that led to the endpoint. And start from decision 4 and we can come up to the code fact. This type of chaining starts from the goal and moves backward to comprehend the steps that were taken to gain this. The backtracking process also enable a person to establish logical steps that can be used to find other important solutions. The backward chaining can be used in debugging, diagnostic, prescription application. The properties of backward chaining are this process is up-down approach, top to bottom. This goal-driven method of reasoning. The endpoint is subdivided into subgoals to provide the backward chaining algorithm is deployed in the one rule that you had already studied in description logic, modus ponens inference rule as basis for backward chaining. This rule states that if both the conditional statement P determine Q and the antecedent P are true, then we can infer substitution. Like a common an example, you can take the information provided in the previous example, forward chaining can be used by this provide a simple explanation for backward chaining. And backward chaining, that way backward chaining can be explained in following. If A determine B, then A can be also true. Is the goal or endpoint as a starting point in this tracking before backtracking. A is the initial point, and A determine B is a fact that must be asserted to the endpoint B. And here, therefore, B starting point, which was earlier in the earlier chaining, so Tom was sweating. Then, if a person is running, he will sweat, so that will be running. The advantages of backward chaining are the result is already known, makes it reduce it. It is quicker method of reasoning than forward chaining because the endpoint is available. In this type of chaining, correct solution can be derived effectively with predetermined rules made by the inference. Disadvantage side, it is the process of reasoning that only start if the endpoint doesn't deduce, it only derives data that is needed, makes it less flexible. As in today's class, we have studied word system in general, and while studying machine learning, we have studied about the forward chaining. So for the references are concerned, these are the two references which follow. Very